vision is terrible, and I can't look at notes and anything else at the same time, and often can't read them. So these days, I basically just have to wing it. So this event is not brought to you by Ververica. I forgot to delete that slide.
A huge hand for Ben Gamble, everybody.
So, hello everyone. Although I normally say I am the technology sommelier, because my job is mostly just to tell you about cool stuff from Kafka, databases, and AI, and occasionally pair cheese with it, my day job is to be the field CTO at Ververica. And though that sounds often for chief technology, these days it's chief talking. I will talk at you repeatedly. Tell me to shut up if necessary. I will not be offended. So previously, I've spent a lot of time building AI and ML systems. Most of my career has been around the idea of simulations and high-speed data. So at one point long ago, I built an AI-powered logistics company. I built a Google Glass company. A lot of these very foolish, in retrospect, ideas. But these days, it basically translates to, if it was cool, I tried to do it, then moved away before the money appeared, which is the kind of story of my career to date. And particularly these days, I mostly work in streaming data and other things. Just before this, I actually used to work at Ivan, where Hugh and I actually met, worked hosting meetups together. But subsequently, I've moved on to Ververica, and on pretty much everything, I'm so lazy to remember things that I just go by Ben Gamble 7. You'll find me by that on LinkedIn, Twitter, or X as it's known, Blue Sky, and everything else. So, quick question. What is Gen AI? And first, hands up. Who's used Gen AI in this room? Good. So most of y'all. So just to set the stage, it's the idea of at least the current large language models say, text in, do some stuff. And that stuff varies wildly, and we would have learned a bunch about it, but apparently not. I was going to reference heavily the talk ahead of me. But no, instead we get text out. This is your kind of classic chatbot type scenario. This is where you use your ChatGPT, your Claude, and everything else, and just get this kind of stuff out. But then we talk about what agents are. Now, hands up here who's used an AI agent deliberately, not just one you're given. Now, my eyesight's bad, so I'm going to say that's about slightly over half the room. And that's quite a change. Because the idea of an agent is to take it from this kind of model to taking an action. Now, this is all just a level set to kind of make sure we're all on the same page. Now, the idea is, of course, that an event comes in. This is the sensor. And then we do some reasoning, some processing, we generate an idea, and we do something with that idea. Nearly always this kind of boils down to some semi-structured data goes in, we do some analysis, and some JSON comes out, and the JSON tells us what to do, like every REST API ever built. And what happens next is, when you start to scale these things out, is you end up with a goal, it hits a queue, you create some tasks via an LLM, and it kind of goes in a bit of a loop until you have things you're supposed to do. And then you end up with some memory of what you've just generated, and then you start executing these one by one, many by many. And the idea of a lot of these agentic systems is that you can basically do a bunch of things one after another. But when you look inside them, all there is still is a prompt, some input, and then some way to respond to that. So this is where it becomes problematic, because LLMs are non-deterministic. This means if you put the same thing in repeatedly, eventually it'll give you a different result. Unless you dial that temperature all the way down, at which point it stops giving interesting results. So you either get things that matter and change, or things that don't and don't. So the value is kind of directly proportional to how random the output can be. And they are actually expensive. Now, they are less expensive by the day, but as you start getting to the bigger models, the more reasoning-powered ones, you get to the point of where you use something like cursor.ai, you flick it onto Max, you put it on the Claude v4 on Opus model, and then you run it for a bit and watch the usage-based pricing has popped up. Please add another $100 to your bill. I did this twice in the last 2 weeks. I am scared to look at what my Claude bill would be, and I think my boss might complain. However, it was very cool. But it does mean that LLM calls, particularly for the more powerful, more potent models, the cost can spiral. And this is where we get back to an even more problematic bit, which is chaining non-deterministic systems. Now, who here has heard of the concept of integration of error? Now, this is me being a very much failed scientist from long ago, and the idea is simple. If there are little mistakes along the way, and you keep adding those results together, the amount of mistakes you have build up over time. And if you keep relying on things one after another that can have mistakes, you're going to get more and more of them. And then if you ask bigger and bigger questions, you'll know that your LLM gives weirder and weirder results, meaning that you start getting this kind of fractal amount of error where you no longer can be sure of anything 10 calls down the chain. Once again, if you've used Cursor, this is when you ask it to build the app and you get a banana. But it's very much one of those things where you do not know what you're going to get as it slowly drifts away from your initial prompt. So what we need determinism, because hallucinations are not good for business. And if any of y'all work in things like banking, that can be really bad. There are already been cases where refunds have been issued by LLMs which should never have been issued. Legal precedents that never existed were being given. And of course, mortgage applications have been denied for no good reason. So the last one, at least, no good reason makes no difference. But you get the point of where these things matter and low marginal costs. Now, this is the real kicker for me and for every single use case I've come across yet, which is if it's cheaper to do with if statements, eventually you will trend to if statements. This is the idea that comes around everywhere in software engineering, which is that eventually your code will be rewritten in C because it was too expensive to be running in JavaScript, in Python, in anything else. And worse still, if it works, we'll want to do it a lot. So your bills are going to go up very high, very fast. I dread to think what some of the margins on some of these LLM-powered use cases are, which are not usage pricing. Because we want to use a lot of things. And this is where scalability comes back. Now, on Cursor, I'm going to keep referencing Cursor because it's the one I've been using today. You get up to 3 windows of chat at the same time. If you try to use most AI-powered things, you can't run more than a certain amount in parallel before it just stops working. You can't take more than a certain number of steps before the determinism goes away. And also, the amount of delay on each tool call gets rather extreme. And if it's good, we want more of it. We always want more of a good thing. It's called wonderful. And then fault tolerance. Everything eventually dies. I have lost very large prompts in various systems from the fact that you start talking at one of those ChatGPT windows and eventually the voice prompt just goes, nah, not going to convert that. Or Cursor just dies halfway through and you've got to unwind the whole stack it just did. And you can't really pick up because fault tolerance is not designed into these things because even most agentic systems, there effectively are numerous layers of API called deep and there's no determinism up and down the stack. So let's solve for some of them. So hands up here who's heard of Apache Flink. 1, 2, some. Wow, more than usual. Either I'm doing my job or this is better than I thought. This is the right place. So Ververica originally created Apache Flink back when it was called Data Artisans. In about 2014, it was given to the Apache project. We're a lot like Databricks, except whereas we were founded in Berlin, they were in San Francisco, and they got all the money and then did a really good job with it. We pretended to be academics for a very long time and did a very good job of making Flink the answer to really hard problems, yet the community is small. But it's built around the idea of a robust real-time processing engine for batching and streaming data. So it doesn't matter if your data is a batch or a stream, we don't care, we'll process it. It scales to almost any workload. So every single thing you do in Netflix goes through a Flink pipeline to allow them to decide what you're going to watch next. And you know how it can be rather uncanny at times about suggesting the right thing? Thank Flink. And if you ever been complaining about Uber's pricing, we did the processing, we didn't do the calculation. That's on them. And the rest of the things are things like the biggest shopping day in the world is called Couples Day on Alibaba, where they're processing billions of events per second. And we're the ones actually on our own platform powering that. And all that has to be nice and easy. So you want SQL support, you want easy ETL. And because I feel I must, it's effectively monads over data. Yes, I mentioned monads once per talk. So where Flink comes in specifically in these kind of things is something called complex event processing. Now, this is the idea of saying you want rules over data. Now, not just like SQL rules of transform into X. I mean things like matching. So you want to match a pattern. Say, I saw the first event, and if I don't see the next event in 10 seconds, do this. Or I saw this event followed by that event, that means this thing happened. The if-then-else type logic with timers and transactional guarantees gives you the ability to start chaining logic together with some kind of understanding of what's happened, but also the ability to kind of roll these sort of things together. And like statelessness, idempotency is an ideal, rarely a reality. Hands up who knows what idempotency means. So, not all. Good, I'll explain. So idempotency means if I do the same thing twice, I shouldn't get a different result. And if I say, hey you, for this exact ID, for this exact amount, and I do it 3 times, it'll only happen once. Exactly once semantics are semantics, they're not exactly once behavior. This behavior is achieved through idempotency. So I call my tool chain 3 times because of retries and accidents, it should only ever happen once. And this is where catching those kind of things becomes very important. And this is where something called stateful or stateful functions, built on top of those previously mentioned complex event processing things happen. This is the idea of saying, I want to use Flink to guarantee that I can call that AI over there, guarantee that it goes through, retry if it fails, but also then not retry and handle the responses back if I do it twice by accident. The only way to ensure reliability on the internet and any other system is to keep going until you succeed, and then deal with the fact it might come back 6 times. And this is where we start looking at agents again. So we start putting Flink agents all over the place. So we can put our queue in Flink. Flink has memory. We can put our task creation in Flink. It runs Python quite nicely. And we can do execution in Flink. So this is the idea of calling out to external systems with guarantees. So already we've got some steps done. So let's take away scalability. So Flink scales to billions of events per second, not a problem. Fault tolerance, reasonably okay. At any point in the time, we already have a stateful step. We checkpoint every event, and we can do that RPO 0 level recovery to say we have called exactly this many steps in our tool chain. So now we need more than the LLM to go next, because we have 2 hard problems left, determinism and low marginal costs. Now, the question I always ask myself, particularly when we come to any sort of engineering and new stuff, is, have we done this before? Because if you remember from reading about this stuff, the AI winter, famously when AI was never going to come around again, was in the 1970s. So I'm thinking, surely some of this thinking's been done for me, because I don't like doing it if I don't have to. And this is where I come back to something where I actually started my career out in, which is agent-based modeling. Now, you've heard of agentic systems for AI, but hands up here who's heard of agent-based modeling? The same 6 people. Awesome. I see some of you also suffered computer science at one point. And this is a tool called NetLogo, which I did on my physics course when I was trying to simulate things and find emergent behavior out of complex events. So you have a few very simple rules and a bunch of agents running around obeying those rules, and famously they cause things to happen. The previous slide is something called Craig Reynolds Boids. This is like that flocking behavior you'll all have seen in many game dev things where they go, I can do scale! And the idea is you make things that look like life. And there's only 3 rules being applied over and over again, and each thing is individually working like an agent responding to those rules. So let's talk about research. So in 1971, yep, we can go back a long way now, there's something called strips modeling came out. And this is a whole thing out of Stanford about how you model behavior and decisions in behavior. Because most agent systems these days are just making decisions. Then there's this thing called Sugarscape, which is a book about doing this kind of decision-making agentic stuff at crazy scale, 1996. And then there's a thing called GoApp, or Goal-Oriented Action Planning, came out in the early 2000s and powered some very famous video games. And games like Fear or First Encounter Assault Recon, if you've seen that, and Shadow of Mordor about 7 to 10 years later. I would go into more detail, but I've trimmed those because the graph theory gets hairy at that point. And it's cool, but it goes a bit deep. So let's start putting this together. So we want to define a goal. And in most of these systems, particularly the ones with older school decision-based behaviors, you set a goal. This is a heuristic to say this is what the system is trying to reach. And we can use an LLM to define what the steps to get that goal are, but we can do a bit better, because then we can use a plan. And planning systems, like pathfinding systems and others, are based on heuristics and cost. This is like how your SQL optimizer works inside your database. It makes a plan, tries to arrange things, sees if the cost is low enough, tries again. If the cost is low and it meets some heuristic, it stops and goes, this is good. And then once we have the plan, we can execute it in a queue and have memory attached. But the fun part here is the LLM is all the way only in one place, because if failure happens, let's say you get halfway through your tool chains, the classic example is, of course, booking some travel thing. Maybe you've got the flight, there's no transfer taxis, and the hotel is booked out. So what do we do then? Do we throw away the chain and start again? No. Instead, we throw what we know we have achieved so far back into the plan, we find what's missing in the plan, and then we generate those. These plans are designed to run in microseconds, not the seconds you get in most LLM calls. I have demos of this kind of planning systems running with 1 million running on my old 10-year-old MacBook Pro. 1 million agents making plans every single tick. And this is how games have worked for ages. If you ever played Age of Empires, when those villagers chose which tree to go to next, those are agents making decisions in microseconds, not milliseconds, not seconds. So we've already known how to do this for a while. So the question is, why don't we do it like this? Because we wanted determinism. Now, planning is cost-driven and repeatable because you have to be able to do it over and over again because the heuristics don't change, therefore it'll always come out with the same answer. But the best thing is it's local only. And the marginal costs get lower and lower over time because we don't need to call the LLMs over again to do the same action or make the same plan because we've already made the decision of what we're trying to achieve. We've already built the steps. We've already chosen which APIs to call. Then it's just a cost-based optimizer to say, well, I wanted a burger, you wanted a hot dog, great, we'll just make that at a deterministic level and leave that alone. The LLM calls become marginally less per setup. Now, scalability is fun. We've had people run at about 7 billion events per second on our platform. You don't need to go that fast, but if you do, please tell me. I'd love to hear about it. And the key thing here is that with something like Flink or platforms like it, you just don't have to worry about that problem. Everyone says they can build microservices. I know, I said this before myself. And then I tried to scale them reliably, and then they died, or they crashed, or I had to deal with the fact that the scaling was nonlinear amongst them. And I needed to have, I had a weird blocking point where I couldn't have parallelism. These things emerge and are very complicated, but at least when the framework was designed to handle this, it's one less thing I've got to do as a developer. And of course, fault tolerance. Now, who here remembers the saga pattern of the good old enterprise integration patterns? This is the idea that two-phase commit sucks, but transactional guarantees are really important. Because if I fail to book my delivery of my food, I want to undo the payment and the order at the restaurant, not just the fact that I couldn't find the rider to deliver my food. So these are the steps you need to be able to unwind. Because if you make a plan, you've got a list of everything you're about to do. And when you decide that thing times out, you've got a list of everything you need to undo. And fundamentally, these are what we can do here, because an LLM call fails halfway through its tool calling journey. Unless you've built the plan separately again, are you going to call an LLM to try and undo the damage it just did? That kind of sucks in my mind. So how about you try some of this yourself? Now this is where I give out some free keys to our software, but mostly it's just because, one, this stuff's all open source. I just happen to have a hosting platform for it. So to start with, you'll need an LLM with an API. Almost any of them will work. Ollama is free. I recommend Apache Flink. This is our cloud. It's free for the first $400 still. But Apache Flink is also just a free download. And in Python, it's literally pip install. Have fun. It's good fun. I will share libraries about it later. Then some libraries. So LangChain4j, this is an actual open source library I helped build for Flink to do LangChain in Flink. This is the Java version. The Python version sucks. I don't like it very much. And I'm mostly a Python dev. The problem here is that LangChain4j was built by a bunch of very opinionated open source developers, mostly at Red Hat. Whereas LangChain, the first one, was basically built at a startup trying to do a land grab. Don't get me wrong, I respect the hell out of their land grab. It was very successful. But it means there is no strong opinions in that code base, and it's a mess. Also, we're talking about scale here, so I'd prefer the JVM to the Python to CPython if I can get away with it. And then you want help and support. So come find me or anyone else online. I'm Ben Gamble7 everywhere, as mentioned previously. On LinkedIn, I have a squirrel and the blind stick on my LinkedIn profile. It will say follow because creator mode, but if you hit follow, I'll add you back immediately. And then just bug me about cool stuff, and I will talk about it incessantly. So thank you very much for listening. I believe this is my LinkedIn.